Greetings of the day. I am Mohini Rasar, working as an assistant professor at All India Sri Shivaji Memorial Society's College of Hotel Management and Catering Technology, Pune. I will be introducing you to this session of physics under the bridge course. The topic for this session is thermal expansion and specific heat capacity. This topic will be covered in two parts. Let's take a look at the objectives of the session. You will be able to understand the concept of thermal expansion and its significance. You will be able to explain the types of thermal expansion, which includes of linear, area and volumetric. One will be able to provide examples of thermal expansion in everyday objects and scenarios. Also, we'll be able to highlight the practical implications of thermal expansion in various fields and learn about coefficients of thermal expansion. So, I welcome you to this session on thermal expansion, where we explore how this fundamental principle shapes the world around us. And you'll be able to have deeper understanding of thermal expansion and its relevance in our everyday lives. Thermal expansion is the tendency of materials to change in size, shape or volume in response to changes in temperature. At the microscopic level, materials compose of atoms or molecules held together by bonds. When these materials are heated, the particles within them gain kinetic energy, causing them to vibrate more vigorously. This increased vibration disrupts the balance of forces between the particles, leading to a temporary expansion of the material. Now, let's understand the types of thermal expansion. There are three main types of thermal expansion: linear expansion, area expansion and volumetric expansion. Let's take a look one by one. Linear expansion. This occurs when a material expands or contracts in one direction. A common example is the expansion of material or metal rails on railway tracks during hot weather, causing them to lengthen. Our second expansion is area expansion. This occurs when a material expands or contracts in two dimensions. For instance, when a metal sheet is heated, it may expand in both length and width. Further, volumetric expansion. This occurs when a material expands or contracts in all the three dimensions. Liquids and gases exhibit volumetric expansion. For example, as water is heated, it expands in all directions, leading to an increase in volume. Now, let's take examples of thermal expansion in everyday objects. Consider a metal bridge on a hot summer day. As the temperature rises, the metal components of the bridge expand, leading to potential structural issues if not properly accounted for in the design. Our second example is railway tracks. During hot weather, railway tracks can expand, causing them to buckle or wrap. To prevent accidents, engineers install expansion joints and monitor track temperatures closely. Our third example is in the kitchen. Thermal expansion is evident in cooking utensils. When you heat a metal pot on the stove, it expands, ensuring efficient heat transfer for cooking. This expansion also helps distribute heat evenly across the surface of the pot. Now let's take a look at practical implications of thermal expansion. Understanding thermal expansion is crucial in various fields, including construction, transportation, and manufacturing. Engineers and architects must account for thermal expansion when designing structures to ensure safety and longevity. Thermal expansion also has practical implication in temperature measurements. Devices like thermometers utilize thermal expansion to measure temperature accurately, making them essential tool in fields such as healthcare and meteorology. Thermal expansion is a fundamental concept that affects various materials and structures in our everyday life. Understanding how materials expand and contract with changes in temperatures is crucial for designing safe and durable infrastructure, preventing damage, and ensuring optimal performance of mechanical systems. By considering this, engineers and construction can develop solutions that withstand the effects of temperature fluctuation and maintain structural integrity over the time. Now, let's take a look at how thermal expansion is expressed. Thermal expansion is typically expressed quantitatively using coefficients of thermal expansion, which is denoted or short form is CTE, which are specific to each material. These coefficients represent the fractional change in size, shape, or volume of a material per unit change in temperature. There are three main types of coefficients for thermal expansion. First one is linear expansion coefficient. This coefficient represents the fractional change in length per degree Celsius or Kelvin of temperature change. It is commonly denoted as alpha, where alpha is linear expansion coefficient, delta L is change in the length of the material, O is original length of the material, and delta T is change in temperature. Second one is area expansion coefficient. This coefficient represents the fractional change in area per degree Celsius or Kelvin of temperature change. It is less commonly used than linear expansion coefficient, but can be relevant for two-dimensional material, where beta is area expansion coefficient, delta is change in the area of the material, delta O is the original area of the material, and delta T is change in temperature. The third one is volumetric expansion coefficient. This coefficient represents the fractional change in volume per degree Celsius or Kelvin of temperature change. It is particularly relevant for all liquids and gases, where gamma is volumetric expansion coefficient, delta V is the change in the volume, then we have original volume of the material, and delta T is change in the temperature. These coefficients provide a quantitative measure of how much a material expands or contracts with changes in temperatures. They are crucial for engineers and designers to predict and account for thermal expansion effects in applications such as construction, manufacturing, and mechanical engineering. Now, let's take a recap on the session. Thermal expansion is the tendency of materials to change in size, shape, or volume in response to changes in temperature. At the microscopic level, materials are composed of atoms or molecules held together by bonds. When heated, these particles gain kinetic energy, causing them to vibrate more vigorously and leads to expansion. There are three main types of thermal expansions: linear, area, and volumetric. Linear expansion occurs when a material expands or contracts in one direction. Area expansion occurs when a material expands or contracts in two dimensions. Volumetric expansion occurs when a material expands or contracts in all three dimensions. Examples include of expansion of metal bridge and railway tracks, expansion of cooking utensils like metal pots on the stove. Understanding thermal expansion is crucial in all the fields and various fields. Thermal expansion coefficients include linear, area, and volumetric expansion coefficients, which are represented as alpha, beta, and gamma, providing a quantitative measure to how materials expand or contract with changes in the temperatures. Coefficients of thermal expansion are crucial for engineers and designers. Linear expansion, area expansion, and volumetric are commonly used to express thermal expansion quantitatively. These coefficients represent the fractional change in size, shape, or volume of a material per unit change in the temperature. Finally, thermal expansion plays a significant role in everyday life, influencing the design and maintenance of structures, temperature measurement devices, and various mechanical systems. In the next video, we will talk and learn about specific heat capacity. Thank you so much.